So this is our last section of this unit, and it's solving rational equations. So up until now, everything we've done has just been an expression, okay? The difference is an equation actually has an equal sign in it, right? So every question we've done so far hasn't even had an equal sign in it now, but now they will. So the first thing we want to do is we always want to make sure that when we're doing these, we are able to eliminate the denominator. So eliminate denominator. Okay, and the way that we do this is that we're going to use our lowest common denominator, and everything will get multiplied by it. So that lowest common denominator will multiply everything. Okay, and we'll do some examples to show that. Okay, so if we look at our first example, okay, let's do something like x minus 5 under 3 is equal to 5x minus 25 over 10. Okay, so first things first is we always want to factor. So some things will stay the exact same, right? We're going to factor it. Our first term looks pretty good. Our second one, we see, okay, we have a GCF of 5. Okay, so first thing is factor. Just like before, we have to state our NPV, so maybe we'll do that over here. NPV, x cannot equal positive 5. All right, so some of it stays the same. One thing we want to do now, though, is we want to look at what our LCD should be. Okay, so our LCD, we know, should represent everything we find in the denominator. So if we look here, we need to have an x minus 5. Okay, and then when I look at my second term, I say, okay, this x minus 5 is already there, so I don't have to include it twice. What I do have to include is this 5, though, right? So my LCD, this 5 here cannot be represented by that one because this 5 is part of this entire binomial, whereas this one's a monomial, right? So we can't combine binomials and monomials that way. So every single thing is going to get multiplied by that LCD. Okay, so I'll show that here. Multiplied by 5 and x minus 5. Multiplied by 5 and x minus 5. Okay, and so what we want to do is we don't want to go and automatically start multiplying this through and stuff like that. We want to see if we can cancel out our denominators. So if I look at my first term, I say, okay, my x minus 5s will cancel out. If I look at my second term, the entire thing will cancel out, the 5 multiplied by the x minus 5. Okay, and then when we look at that, we say, okay, on the left side, that leaves us with a 3 times 5. On the right side, that just leaves us with 10. Okay, so then we get 15, 3 times 5 is equal to 10. And when I look at this, I should say, well, wait a second. 15 is not equal to 10. And every once in a while you'll get this, and it's actually no solution. Okay, so it's kind of a different kind of example to start with, right? So if you get something like that where you get one number is equal to another number, and there's no x involved, like 15 is equal to 10, no solution. Okay, so let's try one where we will have a solution. So if we look at something like, let's do like 1 over x plus 1 over 3x is equal to 1 over 6. Okay, so we look at this and we say, okay, it looks factored, so that's good. Let's handle our NPVs. Okay, so we'll go and maybe write that in the corner. And we have an x, a 3x, and a 6. So I'd say, okay, my NPV, x cannot equal 0. Okay, now we need to look at what our LCD is, because after we've done the factoring and the NPVs, we know our first task is to get rid of the denominators. Okay, so our first term has an x, so we know our LCD is going to include an x. Okay, our second term is a X squared minus 9, that's a difference of perfect squares. Okay, and then I say okay. So I split that up, and then of course 1 over 5 looks good. Okay, so because we factored, we know, okay, now is a good time to maybe deal with our NPVs. So we look at the first one, we say, okay, x cannot equal positive 3. Look at the second term, we have x minus 3 and x plus 3. So the x minus 3 is taken care of, but x can also not equal negative 3. Okay, so let's look at our LCD. So we have LCD. Our LCD needs to represent everything. So we have x minus 3 is going to be included. Okay, when we look at our second term, x minus 3 is there. It's got to include x plus 3. And last but not least, it's got to include a 5. Okay, so everything, every single piece is going to get multiplied by the LCD because we want to get rid of the denominators. Okay, so our top one will have 5 multiplied by x minus 3, x plus 3. Okay, 6 multiplied by 5, x minus 3, x plus 3. And we get kind of crowded here. And then we get 1 multiplied by 5, x minus 3, and x plus 3. Okay, so when we look at it, we say, okay, let's cancel things out. We don't want to start multiplying before we cancel things out. So our x minus 3's are gone in the first term. In the second term, both of those binomials are gone. And in the third one, the 5's are gone, but we're left with x minus 3 and x plus 3. Okay, so let's clean it up. It's kind of a mess right now. So we have 1 multiplied by 5, and then x plus 3, right? So we still have one of those binomials there. Then we have minus 6 times 5. Okay, so I'm going to change that maybe to a 30s and just deal with it already right now. And then very last, on the other side of the equal sign, on the right side, I have x minus 3 and x plus 3. Okay, so my goal for these questions is I want my answer to be x equals something. Okay, so what I'm going to do is I'm going to start using distribution and FOIL, right? First, outer, inner, last, so that I can find out what x equals and I can hopefully start to simplify it. Okay, so we'll start off maybe by doing some distribution. So we have 5 times x, 5 times 3. Okay, so I get 5x plus 15 minus 30. And then on this end, what I can notice about this one is I can say, okay, well, x minus 3 and x plus 3, that's a difference of perfect squares. So if you notice that right away, you can jump right to this, x squared minus 9. Okay, next thing we're going to do is we are going to start putting all of our stuff together. So when we notice that we have an x squared, okay, an x squared means it's a quadratic. So we know that we have to put everything on one side and 0 on the other. In our last example, if we take a quick peek, it was a linear one, right? It wasn't an x squared, it was just an x. And when we have that case, we want to have our x on one side and everything else on the other. Okay, quadratics, though, we know we maybe want to deal with differently. So, first things first, let's put the 15 and the 30 together, okay? We'll do this one step at a time. So I have 5x. 15 minus 30 gives me negative 15 is equal to x squared minus 9. Okay? So I'm going to flip over to a new page. So what did we have? We had 5x minus 15 is equal to x squared minus 9. Okay, the next thing is we are going to say, okay, well, we want everything to be on one side together. So let's minus the 5x from both sides. Okay, so I'm going through this one step at a time. Some people just kind of skip through a lot of these things and jump ahead. We get x squared minus 5x minus 9. Okay, then I have that negative 15 I want to deal with. So I'm going to add 15 on both sides. So plus 15 plus 15. Okay, and then when I look at this, I say, okay, I have 0 is equal to x squared minus 5x, negative 9 plus 15. So that gives me plus 6. Okay, so when I look at this, there's a couple different ways. We can use the quadratic formula. We can graph it. Or this is a nice inspection one, so we can think, okay, what plus what is equal to negative 5? What times what is equal to positive 6? Okay, so I know it's got to be two negative numbers, and it's going to be negative 3 and negative 2. So my factors are x minus 3 and x plus 2. Okay, but what that means is when those are my factors, that means my answers are x is equal to 3 and 2, right? We always flip the signs. So sorry, I drew x minus 2. Okay, so when I look at this, the one thing I always want to check is make sure, do they have any match with my NPV? So if I go back, I say, oh, one of my NPVs here is x cannot equal 3. Okay, and I have that right there. So x equal to 3 is not a valid answer. Okay, so NPV, not valid. It's called an extraneous root. Okay, so my only answer that is valid is x is equal to 2. I'll do a double box around it. Okay, and then of course you want to go back and check, right? So we'd go and we'd say, okay, if I wanted to check, maybe I'll do that just on the side here. Right, I'd say, okay, check. Oops. And I'd go, okay, 1 over 2 minus 3 minus 6, 2 squared minus 9 is equal to 1 over 5. Okay, and I'd put it all in my calculator and I'd find, okay, yep, that's true, it checks out, it's good to go. Okay, so that's all there really is to solving. Remember, we want to factor first. Okay, then we want to find our NPVs and our LCD. Everything gets multiplied by our LCD, right? We can see how we did that here. You do that so you can eliminate the denominator and then you solve for x. And that's all there is to it.